students, you are welcome back to class. Our lesson for today is on the topic
pH scale. So let's take a look at the learning objectives for today's lesson. So here are the learning objectives. First, we'll be defining the pH of a solution. We'll define a pH scale and solve one or two questions involving pH of a solution. So let's start with the definition of the pH of a solution. So we'll be starting with the definition of the pH of a solution. pH is defined as the negative logarithm of hydrogen ion to the base 10. It can equally be defined as a measure of the concentration of hydrogen ions in solution, or a measure of the alkalinity or acidity of a solution. So you take note of that. That is the definition of the pH of a solution. So you take note of the formula you can see on your screen, because we'll be using that to solve for the pH of a solution. So before we solve questions involving pH of a solution, we'll be looking at the pH scale. So that's the next thing we'll be talking about. So what is a pH scale? The pH scale is used to measure the acidity and alkalinity of a solution. It is measured on a scale of 0 to 14. A pH value of 0 to 6 indicates the solution is acidic, while a pH of 7 indicates the solution is neutral. However, a pH value of 8 to 14 indicates the solution is basic or alkaline. Note that acidity increases with decreasing pH value, while alkalinity increases with increasing pH value. So here's a picture of how the pH scale looks like. Like I said earlier, a pH value of 0 to 6 indicates that the solution is acidic, while a pH value of 7 indicates that the solution is neutral. However, a pH value of 8 to 14 indicates that the solution is either basic or alkaline. And note that as the pH value increases, the alkalinity of the solution will increase. So acidity increases as the pH value decreases, while alkalinity of a solution increases as the pH value increases. Let's look at some questions involving pH value. Here's an example. Calculate the pH of a solution with hydrogen ion concentration of 0.001 mole per dm cube. It's a very simple question. You recall I told you to take note of the formula of pH, which is the negative logarithm of hydrogen ion concentration to the base 10. So that's the formula I'll be using when calculating questions involving pH. So how do we go about this question? This question is a very simple one. The hydrogen ion concentration has already been given to us as 0.001. So the first thing you need to do, so we'll be starting by looking at the formula for pH. pH, like you already know, is equal to negative logarithm of hydrogen ion concentration to base 10. So all we need to do is to substitute the value of hydrogen ion concentration. And from our question, the value of hydrogen ion concentration is 0.001. So the first thing we need to do is to express 0.001 in standard form, and this will give us 1 times 10 raised to the power of minus 3. That's what we should get. So we're supposed to express that value in standard form, and we have 1 times 10 raised to the power minus 3. So the next step is to open our brackets. So we'll multiply negative log to base 10 by what is inside the bracket. So we'll multiply negative log base 10 by 1. We'll have negative log 1 base 10. And in logarithm, multiplication implies addition. So we introduce our addition sign. Then we also multiply negative log 10 by 10 raised to the power minus 3. And that'll give us what is inside the bracket. As you can see, that's negative log 10 raised to the power minus 3 base 10. So if we open our bracket, plus times minus will give us minus. So that's why we're having negative log 1 base 10 minus log 10 raised to the power minus 3 base 10. So according to logarithm, this expression can be written as negative log 1 base 10 plus 3 log 10 base 10, because we're taking the negative 3 to the other side. That's negative 3 multiplied by negative log 10 base 10. That will give us a positive 3. And according to logarithm 2, log 10 base 10 is equal to 1. So anywhere we have log 10 base 10, we substitute as 1. So that will give us pH equal to, and the negative log 1 base 10 is equal to 0. So that will be pH equals to 0 plus 3 times 1, which will eventually give us 3. So let's look at the second example now. Example 2. Calculate the pH of a solution with hydrogen ion concentration of 0.003 mole per dm cube. So it's just like the previous question. So the difference here is that we're having 0.003. So the first thing we also need to do is to write the formula for pH. And if you recall, I said earlier that the pH is expressed as negative logarithm of hydrogen ion concentration to base 10. So now let's see the formula. So here's the formula. pH equals to negative logarithm of hydrogen ion concentration to the base 10. So you recall that our hydrogen ion concentration for this question is 0.003. So we have to substitute that into the formula. So this will give us negative log 0.003 base 10. Like I said in the previous example, we need to convert this value to standard form. And you know that this will now be equal to 3 times 10 raised to power minus 3. So you take note and we substitute that in place of 0.003. Next, like I said in the previous example, is to open the brackets. So we open the bracket by multiplying negative log base 10 by each term in the bracket. So that will give us negative log 3 base 10 multiplied by negative log 10 raised to the power minus 3 base 10. So like you recall, I said multiplication in logarithm means addition. So that's why we're having the plus sign there. So the next thing we need to do is to open our bracket. So opening the bracket, you have negative log 3 base 10 minus log 10 raised to power 3 base 10. So you take note of that. And you recall, like I said in a previous example, minus 3, we had to rearrange it such that we multiply it by the minus in front of negative log 10 base 10. So this will give us a positive in front of it. So we have negative log 3 plus 3 log 10 base 10. And like I said earlier, you recall log 10 base 10 is equal to 1. So anywhere we have log 10 base 10, we replace it by 1. We have pH equal to negative log 3 base 10 plus 3, because log 10 base 10 is already 1. So that'll be 3 times 1, which will eventually give us the same 3 you're having there. So using your calculator, you have that negative log 3 base 10 is equal to negative 0.48 plus 3. That will eventually give us our final answer, which is 2.52. You can see it's a very simple process, just for you to remember the various steps that we applied in solving the question. So basically, this is how we calculate for the pH of a solution.